Okay, Year 12, I'm going to do the next video lesson for the work that we need to do. Some of you probably already have worked into it, but it's a good idea to check it because sometimes you might be doing things and there might be alternate ways or easier ways to understand the problem. So even though you might be getting the right answers, watch some of these all the way through so you can see the different types of techniques we use. So today we want to talk about the arithmetic series, and remember, a series is what we get when we add them up. All right. So the arithmetic series. So let's look back at a famous mathematician, Charles Frederick Gauss. Okay. Now Gauss was famous for having, better get a picture of him. So Gauss, Carl Frederick Gauss, there he is. When he was only a little boy of about 6 years age, the story goes that his maths or his teacher wanted to occupy the students for some time. So he told all the students to add all the numbers 1 to 100. So let's think about that. 1 to 100. 1 plus 2 plus 3 plus 4. And we go all the way up to 100. Now, before the teacher had been able to sit down or step out of the room, little Carl Friedrich Gauss said, I've got the answer. And this is what he did. And this is a stroke of genius and leads us to being able to work out a formula for the sum of any series, because this is an arithmetic series. This is an arithmetic series where the common difference is 1. The common difference is 1. But anyway, here's what he did. He said, okay, I'm going to write half the series up here, 1 plus 2 plus 3 plus 4, all the way up to 50. And then I'm going to write the other half of the series backwards, 100 plus 99 plus 98 plus 97, all the way down to the bottom half, 51. And if you add each of those lines together, if you add each of those terms together, what do you get? Oh, 1 plus 100, 101. 2 plus 99, 101. 3 plus, oh my goodness. All of those pairings add up to 101, and there are 50 of them. So to do this sum, he just had to do 50 times 100, and 1. And that's pretty easy because you put your 0 down, 5 times 1, 5 times 0, 5 times 1, 5,050. And you can do that for any series. And let's look at what he's done. He's halved the number of terms. He's halved how many terms there were. And he's taken the first and the last term to find out what they all add up together. Now you can do that for anything. Imagine if you are now counting 1 to 1,000,000. So 1 to 1,000,000, so 1 plus 1,000,000 times half of 1,000,000. Half the number of terms, 500,000. Oh, so 1,000,001 times 500,000. And of course, you put all those zeros down, 1, 2, 3, 4, 5, 5 times the 1. Then you put all those zeros down, 1, 2, 3, 4, 5, and then you put the other 5. That's what all the numbers add up from 1 to 1,000,000. How cool is that? And you can apply it to anything. You can even add up to an odd number, all right, because you just take that odd number out and do the series up until then. So, for example, if you were adding the numbers 1 to 79, so 1 to 79, well, you just go, I'm going to go 1 to 78, and I'll keep the 79 separate. I'll keep the 79 separate. I'll take it out. I'll just keep that over there to the side. So I've got 79. Oh, isn't that interesting? Yes, it is. 79. And how many? What's half of 38? Well, half of 38 is 39. So plus I've got one more. So I've got 40 times 79. And you just use your calculator for that one. So 79 times 40. And it's 3160. So now Gauss did that at the age of 6. That's a remarkable bit of smarts. And look what we've got. How do we work the sum of a series? Here it is. It's n over 2, the number of terms over 2, times the first and the last term added. The first and the last term added. Brilliant. Brilliant. Now, even though we can see that systematically by doing those individual questions, we're going to do it algebraically. So here's the proof. So when we say the sum of a series, we use this term, S of n, the sum of n terms. And if we write this series out, there's the first term, A, there's the second term, A plus D, there's the third term, A plus 2D, all the way up till we get this last term, which we're now going to call L. Now, if we write that series backwards, L plus the last term minus D, plus the last term minus 2D, and so on until we get to A. Now, if we add these things together, if we add these two things together, well, we'll get two lots of the series, two of them. And A plus L is A plus L. A plus D plus L minus D, the D's are going to cancel each other out, A plus L. A plus 2D minus 2D, they're going to cancel each other out, A plus L. And then we get the last one, we get A plus L. Now, how many did we do? We didn't halve it, we wrote the whole thing out, so we have n terms. So A plus L, and we're going to have it n times. So the sum of two series is n times the first and the last term, but you want the sum of one series, and there it is. S of n equals n on 2, A plus L. But what happens if we don't know the last term? We could find it. We could find the nth term and put it in, because this is just, L is just the nth term. Yes, and our formula for that is A plus n minus 1 times D. That's the nth term. That L is the nth term. There it is. So we just put that in for L, and this pops out. So think about it, n on 2, A plus n minus 1 times D. We'll give that a square bracket. You get 2A's, n over 2, 2A plus n minus 1 times D. Now, sometimes that formula is easier to use because you don't need the last term and you just sub in n, you sub in D, you sub in A. But if you've got the last term, that's really cool, that method. And you've got to thank Carl Friedrich Gauss for that. Anyway, let's have a look at how we do some of these questions. Now, some of the first ones I'm going to let you just rip into. And remember, the more you do, the better you'll get. So here we go. Exercise 103. So if we find these and we do a couple, and I've got the answers on another computer screen, so I'm just looking over there to check. So I'm just going to use the first formula. So S of n, and it's a good thing to write it out, equals n on 2. I've even started to write it wrong. N on 2, 2A plus n minus 1 D. Okay, so the first one, we're finding S of 15. Okay, here we go. 15 on 2. It's an odd number of terms. Don't let it worry, it's going to all pump out. 15 on 2. 2a, or 2 times, the first term is 4. So this is question 1a. 2 times 4. What's a common difference? Well, 3. So plus 15 minus 1 times 3. Now, I know you're all going to go, can I just do this bit in my head and write 14 times 3? No. No, because you need to show your substitutions. And then you just whack it in your calculator. I'm going to do it by hand. So we've got 15 on 2 outside of 8 plus 14 times 3. I will do this bit on my calculator though. What do we got? 7.5, I've done the 15.2, times brackets 8 plus 14 times 3. 375. So if I add the first 15 terms, I'm going to get 375. And it's important to know that if you get a fraction or something, unless it's a fraction in the series or it's a fraction in your D, you've probably got it wrong. You need to make sure you check that. So down here you might get a fraction, but most of these others you're going to get a whole number, and that might have meant that you've stuffed up. So these are pretty easy. That one, first 30 terms. Let's do one where we have a negative. All right, so we'll have a go at 3. By the way, you should go away and do those ones and then come back to this. So we're going to find S of 25. Righto. Let's just do 3a. What have I got? A is negative 2, and I'm finding 25 terms. So 25 over 2. A is negative 2, and the common difference, the common difference here is going to be 3. We're just going to have a negative 2a. I might have to do 3b because 3b is actually, we're adding a common, yeah, okay. 5 minus negative 2, that's 7. So 2 times a, so 2 times negative 2. And remember to find the common difference. Did you hear what I did in my head? 5 minus 2. That's 7. The common difference is 7. And we're finding 25 terms, so plus 25 minus 1 times 7. Right? Equals. I'll just rub this out now so I don't abuse the equal sign. Equals. And I'm just going to do that on my calculator this time. I'll do the whole lot on my calculator. That's how you should be doing it. So, bang, what do we got? 25 over 2 times 2 times negative 2 plus 25 minus 1 times 7. And I'll just check that because I don't want to make a mistake. Question 3, 2050. Beautiful. 2050. I did want to do a negative. This one, minus 4, right? Because you've got to remember it's a series. You've got to think of this as 5 plus negative 4. And to find the common difference there, so I am going to do 3b. You got another crack at it. So S of 25 is 25 on 2, 2a, 2 times 5, plus 25 minus 1 times d. Now what's d? I just subtract 2 terms. So negative 4 minus 5, negative 9. I'm adding negative 9. That's why it's going down. Don't let the negative fool you. So negative 9. And when I sum all this up, I'm going to get a big negative number. All right, I want to leave that there. So we know where it came from. And I'm just going to do this now. And because my calculator's already got 25 on it, this should be easy. So if I just use my back arrow, what have I got to do? I've got to change that to 5. And I've got to change that to negative 9. I get negative 1, and that's wrong. Have I done something wrong? 25 on 2, 2 times 5, 25 minus 1 times negative 9. 3b, the answer is negative 2,575. Have I written that out right? think I've written it right. 5, negative 5 minus 5, negative 4 minus 5 is negative 9. Let's just check that. So we'll do negative, get out of there, negative 13 minus 4. Well, that's plus 4, negative 9. So my D's right. Must have done something wrong with my calculator. Let's do it again. 2 times 5, 25 minus 1. Are we finding the 25th term? We must be. Times, the negative, I've just put a negative, I didn't put a 9. There we go. Negative 2, what was it again? 2575. Beautiful. Righto. So, most of those will be all right. When you get to 5, so you're going to be okay with those, but when you get to 5, they've given you the last term. So you use the other formula because it's so much quicker. So I'll just do 5a and I'll do 5j. You go and have a go at them yourself. So 5a, it's, this time we're using S of n equals, and we're using Carl Friedrich Gauss's formula, n over 2, a plus L. Okay, so n over 2, well, oh no, we have to find how many terms are in the series. We have to find how many terms are in the series. So we have to find T of n. So over here, remember T of n equals a plus n minus 1 times d. Well, we're told the last term is 535. And our a is 15. So a is 15 plus n minus 1 times, what's the common difference? A common difference, 5. But I'm going to write it because I'm thinking I'm in an exam. 20 minus 15 is 5, is a common difference. So times 5. So what am I going to do? I'm going to minus the 15. So 520 equals 5 times, I'll write it the same way. Okay. n minus 1 times 5. Divide by the 5. Well, 5 goes into that once, that, and into 24 times, 104. n minus 1 equals 104. So add the 1, 105. There are 105 terms. Okay. So we're finding S of 105. So 105 over 2, the first term is 15, the last term is 535. 15 plus 535. And again, this is calculator work. So 105 divided by 2 times brackets 15 plus 535. All right, I'm just going to double check that. And the first one in question 28, yep. So what do we get? 28,875. So I will do 5j. I'll do it over here, 5j. And what do we got? How many terms? Let's find out how many terms. Sometimes it even helps to write, well, what is your A? So my A is 1.5. My L is 25.25. My D, I'm just going to subtract the first two terms because it's easy. 1 3/4 minus 1.5. 1 3/4 minus 1.5. And that'll be 1/4. So there's my A, my D, my L. I have to find T of n. T of n equals A plus n minus 1 times D. And we know that the final term is 25.25 because that's what we're summing to. A is 1.5 plus n minus 1 times 1/4. So this is what I'm going to write. I'm going to do this all in one go so I can do it on the calculator. I'm going to subtract that 1.5, 25 1/4 minus 1 1/2. I'm going to do it all in one go. And I can either multiply by 4 or divide by 1/4. Multiply by 4. And that'll give me n minus 1. Well, let's see what that gets us. So I'm going to need a mixed fraction. So 25 1/4. Put the brackets in. Minus 1 1/2 times 4. Oh, what have I done? Oh, I've got to do it all again. Goodness me. I had the wrong bracket in. So bracket 25. Delete that. I'll get the fraction up. 25 1/4. Oh, this pen's so fiddly. Minus 1. Oh, fraction 1 1/2. Right, times 4. 95. Whew. 95 equals n minus 1, add 1 over 96. Now here's an important point. If you ever get a fractional value for n, you're wrong, because it's got to be a whole number term, it's got to be an integer, unless you're doing a greater than or less than, which means you then go to the next one up or the next one down. Okay, so remember we're using S of n equals n on 2 a plus L. So this is a lot easier. So our n is 96 on 2. Our first number, 1 1/2 plus 25 1/4. And again, calculator work. And if I go in here, I can just do it. Because I've got the two terms there, I don't have to do them again. I'll just add them. And this time, instead of timesing by 4, tell me I did that wrong. Bugger. I've got to fix that. Back up. 1 1/2. And this time we're timesing by 96 over 2. I just wrote divided by 2. 1,140. Okay, let's double check that on my computer. What are we doing? 1,200. Is that 5J? 1,284. What did I get? 25 1/4. 96 divided by 2. First plus the last. I must have done something wrong. What have I done wrong there? 1,284. Did I get it right terms? Did I get the right terms? A plus L, the last term. Have I got it right? Is it 25 1/4, 1 1/2? It's going up by 1/4 every time. It's going up by 1/4, so my common difference is 1/4. Let's just check that calculation, see if it is the 96 term. So 25 1/4, let's just what is that? This calculator's freaking me out. 25 1/4 minus 1 1/2. Right. Now to do it all again. Minus. Go get yourself a cup of tea. And Let's just do divided by a quarter. I'm pretty sure, no, I know that's divided by a quarter. I know that's 1/4. 95, add 1/96. That's right, that's right, that's right. A quarter's right. A quarter's right. A is right. It is 5J, isn't it? We're going to have to come back to that. For some reason, that's wrong. Unless Margaret's made a mistake. 1,284 is what she gets, and I get 1,140. I'll just try it again. It is one. Okay, we'll try it one more time. Is it 25 1/4? Have I been making a mistake? Yeah, it is 25 1/4. So 25 1/4 we'll add to 1.5, because that's the first and last. It doesn't matter. I've done that 3 times now. I'm really getting cross with myself. Plus, I'm just going to write 1.5. And what am I multiplying that by? N on 2. 96 divided by 2. Oh, no. Oh, no. Oh, no. 25. And 1/4 plus 1.5 bracket times 96 divided by 2. Oh my goodness, that was where I made the mistake. Everything was right. I must have typed in a different number other than 96. I must have typed something else. 1284. Okay. All right. So that's how you do those ones. That's 5. Let's do a couple of worded ones. There are 19 of them. They're going to get a bit harder for you. Make sure you text me. So how many terms are needed to give that sum? Let's do one of them. Let's do 9. So 9. How many terms are needed? How many terms are needed to give that sum? So S of n equals 104. A equals 20. D equals, subtract 2 terms, 18 minus 20, equals -2. So we've got a common difference of -2. All right, it's going down. How many terms are going to? Okay, so let's use this one. S of n equals n on 2, 2a plus n minus 1 times d. And what we've got to get is n. This is going to be hard because we've got 2 n's in there, but let's see what pumps out. 104 equals n on 2. A is 20, so 2 times 20, plus n minus 1, we don't know, and our common difference is -2. Okay, so let's multiply that 2 across straight away. So 208 equals n. I'll multiply the 2 across. What do we got in the brackets? 40. Let's expand this. -2n plus 2. Okay, so I get n brackets -2n plus 42. Okay, and that's going to equal 208. Oh, okay, let's multiply that out. 208 equals -2n squared plus 42. Oh, a quadratic. That's okay, we can solve it. Let's take the 2n squared over here, minus the 42n, and we've got the 208. And that equals 0 now. Oh, yeah, we can solve this. Let's divide everything by 2. So you're going to get n squared equal minus 21n plus 104 equals 0. Two numbers that multiply out to 104 and add up to 21. two numbers, 104. Have to play with the calculator now, or we could go straight to the quadratic formula. So, I don't know, 20 and 4, but they've got to be negative. They've both got to be negative. So, let's try 20. Well, 24 add up to 21. So, 104, let's go searching. Divided by, I don't know, 16. 6.5. Okay, 104 divided by 12. No, 104 divided by 14. No, 104 divided by 18. No, I'm going to go to the quadratic formula very soon. I have to get a whole number. N has to be a whole number, so there's going to be a single solution to this. So 104 divided by, what do I need? Oh, let's try 4. 26, no. 104 divided by 8. 8 and 13, there we go. So, n minus 8, n minus 13 equals 104. So that means n can equal 8 or n can equal 13. And if you're thinking about that, yes, what's going to happen is you're going to add these numbers, right? You're going to add these numbers slowly because they're going down, and they're going to start with 2018, and you're going to get up to an amount, and then it's going to go over that amount, and it's going to come back down. It's going to come back down. So you're going to hit the amount once. You're going to keep adding amount, but you're going down in the series, right? So you might get to 104, but you've only got to add a couple more terms, and then it starts coming down again. So our two answers are both perfectly legitimate. And let's just check. I don't want to be making these wrong again. And question 9, the 8, and you got to write that, the 8th and the 13th term. All right, so that was pretty difficult. Probably would have jumped to the quadratic formula a bit sooner. All right, so I want you to have a go at those. Why don't we do one that's got some algebra in it. So I'll have a go at 15. Show that x plus 1, 2x plus 4, 3x plus 7 are the first three terms in an arithmetic series, and find the sum of the first 50 terms. Okay, so 15, x plus 1, 2x plus 4, and 3x plus 7. 2x plus 4 and 3x plus 7. Now, if there's arithmetic series, this term minus this term has got to equal this term minus this term. So, for an arithmetic series, and we did this last time, t of n minus t of n minus 1 is going to equal t of n plus 1 minus t of n. I'm just subtracting two consecutive terms. So, 2x plus 4 over, doing a GP, minus, use parentheses, x plus 1, probably should put parentheses about both of them, has got to equal 3x plus 7 minus 2x plus 4. Okay, so left-hand side, because we've got to prove it, equals 2x plus 4 minus x minus 1, which gives me x plus 3. Well, what about this side? The right-hand side equals 3x plus 7 minus 2x minus 4. 3x minus 2x is x, 7 minus 4 is 3. Beautiful. Left-hand side equals right-hand side. Therefore, series, arithmetic, QED. Right. So we've done that. What else did we have to do? We had to find the sum of the first 50 terms. Well, what do we know? Well, we know the common difference, and we know the first term, and we've got to find t of 50, then find s of 50. So a equals x plus 1. D equals x plus 3. T of 50 equals a, x plus 1, plus n minus 1, 50 minus 1, times d, which is x plus 3. So I get x plus 1 plus 49 x plus 3, which is x plus 1 plus 49x. 3 times 49, can't do that in my head. 147. So I get 50x plus 148. Now I need s of 50. I'm going to use Gauss's formula, which is 50 on 2, the first term, x plus 1, plus 50x plus 148. I'll put brackets in there even though I don't need them. 50x plus 148. So I get 25 x plus 1 plus 50x plus 148, which gives me 25. That's 51x plus 149. Please be right, I don't want to do this again. 25 times 51, 25 times 51, 1,275x plus 25 times 149, 3,725. Please be right, please be right, please be right. And we're looking at 15. Oh, they just wrote it in factorised form. They stopped there. Brilliant. Brilliant. Okay, so that's the next exercise. I want you to have a go at that. Remember, you need to be thankful to Gauss, and the 6-year-old Gauss was able to do that. Quite amazing. And have a go at those formulas. Email me so I know how you're going. You need to email me. Even if you email me to say, going good, got them all right, easy. Anyway, good luck. And remember, our Zoom meeting's coming up.